So number 36 reads, Homer Simpson actually invested $100,000 5 years ago at 7.5% annual interest. If he invests an additional $1,500 per year at the beginning of each year for 20 years at 7.5%, how much money will he have 20 years from now? And he says at the beginning of each year, so this is an annuity due problem, but I'm going to do it without changing the settings. I recall saying yesterday that I showed you how to change the parameters on your calculator, and then I said that I'm not going to change the parameters. I'm going to leave it. The only reason I could think of to change parameters would be an annuity due problem, but this particular one I'm going to just leave it set in end mode, not begin mode. So first, let's see. I'm going to make this a two-step problem. First, let's look and see what the $100,000 that Homer already deposited 5 years ago, what is that going to be worth 20 years from now? So for that, we'll set n equal to 25, deposited 5 years ago, so it's got 5 more years to go. It's already been accumulating interest for 5 years, so that's a total of 25 years of compounding interest at an interest rate of 7.5% per year. And of course, the present value was present value was 5 years ago. He deposited $100,000, and there's no additional payments. I'm going to make this again a two-step problem. So this is step one. Step one is just dealing with the $100,000 deposit from 5 years ago. What is that worth 20 years from now, or 25 years from when we deposited? So ignoring the annuity part for now. Solve it for future value. Press compute future value. You'll get, or I get 609,834. And could you confirm these numbers for me? Because there's a lot of buttons rapidly, and Okay, so that's what the initial deposit is worth. Second step, I'm going to deal with the annuity portions. It also says he's depositing $1,500 per year for the next 20 years, but they're being made at the beginning of each year. So what I'm going to do is, actually step two is really kind of 2 steps. Step two is really, it's finding the value of the future value of this 20-year annuity. When dealing with annuity, n is always a number of annuity payments, so set n equal to 20. The interest rate is still 7.5. You don't need to change that number in your calculator. You don't have to re-enter it either. I'm not using the future value register, so put a 0 in there. And of course, the payment is $1,500. Actually, I should put a negative sign in front of it because it's a payment, not a receipt. So negative $1,500 would be the cash flow. And solve for future value. And we'll get 64,957. But that is the future value. It says that the payments are being made at the beginning of each of the next 20 years. So the last payment is actually when? At the beginning of year 20, which is 19 years from now. But we need to know what that's going to be worth at the end of the 20th year, not the beginning of the 20th year. You follow me? So this future value is a future value of a 20-year annuity at the end of year 19 or the beginning of year 20, because it's annuity due. The last payment was made at the beginning of year 20, not the end. So to find out what this is worth at the end of year 20, which is what we want, so we can add it to this, which is also this is what the $100,000 is worth at the end of the 20 years from now. To put this at the same point in time, we have to allow that amount to accumulate interest for 1 more year. So we're going to multiply it by 1.075, or you can just put it n equals 1 and set that equal to present value and future value if you prefer. Or just multiply it by 1 plus the interest rate. To find its future value, that is the value at the end of the 20th year as, let's see, 64,000. Can't see. Sorry, 69,829. So we have future value in total, then just add the two together. as the future value of the $100,000 savings from 5 years ago, plus the future value of the 20-year annuity at 1,500, 69, 829, for a total of $679,663. That's how much Homer will have 20 years from now.